So we have quite a few questions on how to work with sine, cosine, and tangent, and also how to use the inverse function. So I thought I would take a moment to go through both the material from day 1 and day 2. So if you look and see what I have here, these are one question with 3 parts from our first day's material. And so what it's asking us to do is figure out which trigonometric ratio should be used for each of the following triangles, and then using that to set up and solve for x. And so now, rather than just tangent, we're using sine and cosine as well. We have an acronym to help you remember which one to use then, and it's SOHCAHTOA. I like to write it like this. SOHCAHTOA. And so what that's telling me is that I would use the sine function if I have opposite and hypotenuse, or I'm looking for opposite or hypotenuse and have the other. I would use the cosine function if I have adjacent and I'm looking for hypotenuse, or if I have hypotenuse and I'm looking for adjacent. And I would use the tangent if I'm looking for opposite or adjacent and I have the other. Okay. So that's the acronym that I'm going to use to help me. On each of these problems, I'm going to do a little bit of pre-work to get myself set up. So the first thing that I'm going to do is I'm going to mark the angle that I'm given, and I'm going to draw an arrow straight across from it. That is my opposite side. The opposite and the hypotenuse are the two that are easiest to identify. The other one that's easy to identify is the one that's across from the right angle. That's always our hypotenuse. So I've got opposite and hypotenuse. My last side would be the adjacent. Now, what you're going to notice about this adjacent side is I have no side length and I don't have a variable, so I don't need it. I'm just going to cross it off. So then I notice that I am looking for opposite. I have hypotenuse, and that means I'm going to use the sine function. So it's always the trig function and then the angle measure is equal to, and the order matters, so opposite goes on top, hypotenuse goes on the bottom. Now my personal preference is to turn it into a proportion, so then I can use the cross product property. When I do that, I will multiply x and 1, 17 sine 22, so I will get x is equal to 17 times the sine of 22, which is 6.37. That would be my final answer. All right, I'm going to do one more of these because I want to keep this at an appropriate length for all of you, so you're not watching this all day, and I think I will choose number C for that. Number C. Letter C. Here we go. All right, now on this one, again, I'm going to go through the same process at the start. I've got my angle. I'm going to draw an arrow straight across from the angle I'm working with, and that'll be my opposite. An arrow across from my right angle is my hypotenuse, and the leftover side is the adjacent. Now what you should notice on this one is that we're going to cross off a different side. The opposite side is now the side that I don't have any value at, no variable, no number. So I'm going to use adjacent and hypotenuse, which means I'll be using the cosine function. Okay. So my setup, I have cosine of my angle, 60, is equal to the adjacent over hypotenuse. Again, the order matters. So x over 6. I'm going to turn it into a cross product again. So I'll get x is equal to 6 times the cosine of 60, which is 3. Now, looking at this triangle, that messed with me when I saw that was a value of 3, and it looks to be the longer side of a 30, 60, 90 triangle, but this triangle, notice, isn't drawn to scale. Okay, so that 60-degree angle should actually be a lot bigger. That looks closer to a 30-degree angle. So remember, our figures aren't always perfect, so make sure to think about it logically. And so thinking back, that other angle would be 30, and in the 30, 60, 90 triangle, the short side would be half the hypotenuse, so x should be 3. So now I wanted to work through 2 from the day 2 worksheet, where we're finding angle measures. So the nice thing about this is it doesn't change a whole lot. It's just kind of that last step of our problem that's going to change. We're still going to be labeling the sides, hypotenuse, opposite, adjacent. We're still going to be identifying what trig function. The difference is, because we're finding an angle, we're going to be using the inverse functions. All right, so I'll write my acronym back down up here. I've got SO, Ka, TOA. A little reminder to myself that instead of the traditional sine, cosine, and tangent, when I'm looking for an angle, I will use either the inverse sine, the inverse cosine, or the inverse tangent. So I'm going to work through 3 and 4. Again, these are problems from the day 2 worksheet, just your practice. If you needed the extra help, follow along, and this will help you get 2 of them done if you were stuck at all. All right, so starting with number 3, first of all, I've got the angle that they label right here. That's angle theta. I'm going to label the side opposite O, the side across from the right angle H, and the leftover side as A. Now, just like before, I'm going to cross off the one that doesn't have any information at it, and then I'm left with A and H. So A and H, I'm going to use my cosine function. And the setup will be the same. So it'll be the cosine of the angle is equal to, and it's still order matters, so 6 over 9. Now, once I get to this point, it's asking me to find the angle measure. So I need to undo that cosine function. And the opposite of cosine is the inverse cosine. So really what I do is I take the inverse cosine of both sides, which cancels those ones out. And so I'll find my theta by doing the inverse cosine of 6 over 9. Now, this is a good time for me to put in a plug for the e-graphing calculator that is free for everyone to use. If you go on to our Canvas site under helpful links, there's a link to this free calculator that anyone can use. It works just like the graphing calculators we have in class. It's really, really helpful. Okay, if you need help finding that, let us know. And now that I've typed that in, I get 48.19 degrees. And thinking about that logically, I think that makes sense. So I'm going to move on to number 4. So again, on here, I'm going to go through the same process. I'm going to identify the angle that I'm working with. I'm going to draw an arrow opposite or across for the opposite side. I'll draw an arrow across from the right angle. That's my hypotenuse. And the leftover side is my adjacent. The next step is to cross off the one that doesn't have any information at it, and that is the hypotenuse in this case. And then noticing that I have opposite and adjacent, that means I'm going to use the tangent function. So the setup, I've got the tangent of the angle is equal to, and order matters, so I have opposite on top and adjacent on the bottom. So I'm looking to solve for the angle measure, that's theta right there. So I need to get rid of this tangent, and the opposite of tangent is inverse tangent. I'll do that for both sides. I'll get theta is equal to the inverse tangent of 11.9 over 10. So, typing that in, I'm going to get 49.96 degrees for my angle measure. So hopefully that helps with a little bit of clarity. If you need any extra help, again, reach out to any and all of us as geometry teachers because we really want to help you. Have a great day.